folks, I'm over here doing a throttle potentiometer, throttle control repair on my mobility scooter. And I wish I knew how to do this the correct way a long time ago, like I do now, because while it's still difficult, it's a lot easier than how I used to do this. I'll show the disassembly. I can explain it really quick. There's, in my particular scooter, there's two screws. It's a Merit's Pioneer 2, by the way, Merit's Pioneer 2. There's two screws on either side that are machine screws that are threaded into this black metal. And the other screws are actually wood screws that go into this plastic. And they just have little wood screw threaded clips that pop on there. They sell those at Harbor Freight, by the way, in a nice little kit if you lose any. And you can see they just kind of clip on here, and then you put the other plastic over and you screw there. And so there's two of those on either side as well. Then you can disassemble this panel. There are these little clips here, you can see, that if you squeeze down on these little clips, like right here, you can pull out the plug. And the plugs are, let me kind of explain it a bit. This is for your speed dial, your LED, which is actually very important because that will give you error indications. It's actually an LED hooked up to the microcontroller. You have your really crappy battery gauge, which is hooked up directly to the power supply. And then you have your charging port, which is also hooked up directly to the power supply. Here you have these three wires, which go to the microcontroller, and they measure this potentiometer. That's what I'm going to be fixing today. And then these wires are for turning over your key, which also goes to your your microcontroller and lets it know to let it, start up. So what happens is these come out of alignment. They can also get dust and dirt and stuff in the contacts, but I don't think that's usually the problem. What usually happens is when you're moving these, driving your chair, you can see there's a little spring tension here and then just a metal bar. But the metal bar is, if I can get a good shot here, it's mounted onto the shaft of this potentiometer with two lock screws. It is not a knurled or type D shaft potentiometer, which means that it doesn't have a key. It's just a smooth surface that you're applying force with these Allen nuts, these threaded Allen nuts. It's a really terrible design. It's a really last-ditch resort for potentiometer mounting. And this one's particularly bad because of all the weight this has and because of the angular motion. If you turn it like so, you don't want to press down or up, very easy to do, you can actually start to deform the shaft of this potentiometer. There's other problems with it that I explained in another video when I did a tear down and brought this onto my workbench. But needless to say, it's a really, really bad design, and I'm going to be designing something better. However, in the meantime, I need to go places, and I'd like to have this working. So I'm going to tell you all how you can do this in the most simplest method for a proper alignment. So what'll happen in my particular chair is, if this thing is out of alignment, I'll turn the key over and this will start blinking. And that's just an error indication, usually meaning that this is not working. There's other causes of that, like if you're in the manual push mode, it will also do that. If you have other errors, it'll do that. But for me, it's mostly this thing is out of alignment. And what that means is that it's basically, you see there's this dead spot right in here. It's actually turned on right now. There's this dead spot right in here where nothing's moving. It needs to start up in that state. When you turn the key over, it needs to be in that dead spot. If it's not, let's see if I can do this with one hand. Maybe I have like if I hold this down and then I turn the key, I'm gonna get that that blinking error. You see the blinking error there? Blink, blink, blink. So that's the error code. And depending on the number of blinks, if you get the manual, it should tell you what that error means, but I already know what it means. Now, I believe I've got it calibrated somewhat okay in the dead zone, because now when I turn it over, it's fine, right? But I need to continue calibrating this because you see with the slightest little pressure, it starts to go in reverse. However, if I want to go forward, it doesn't start actuating forward until there. What does that mean? That means I'm not going to be able to get up to full speed, and it means I'm much more likely to go out of calibration as I go forward and reverse throughout my day. Not good, not what I want. So, how to calibrate it. First thing you need a flathead bit like so. And then you're going to need a 2.5 millimeter Allen wrench like this. And you have to keep in mind you have 2 Allen bolts, including this one that's particularly hard to get down there. And so what I've been doing is, especially once I have it in the sweet spot, I can just turn it on and adjust it like so. But if you don't have it in the sweet spot, try to get everything mounted like this, everything all together. Or if it already is mounted, then you can start off this way. And just loosen these bolts just a bit. I'm doing this with one hand, which is crazy. But because I'm holding the phone with the other hand, but I think I can do this one hand. It's time to show off my pro moves. All right, so I just loosened those bolts a little bit. They're still in there, maybe only half a turn each, not a whole lot. And then you want to go in with your screwdriver. And actually, I'm going to opt for a different screwdriver this time because I want something where I can actually feel the slightest movement of sensitivity, because this potentiometer is very, very sensitive. It's another part of its design I don't care for, I must say, is how absolutely precise it has to be, because it has a very, very finite, very specific logarithmic curve. Here's the part number, by the way, should you manage to find a replacement. CM4637, I believe it is. It's a 5 kilo ohm pot, but it's, like I said, it's got this very, very strange logarithmic curve, which makes it hard to source. And DME resellers, durable medical equipment resellers, like to charge out the nose for this part, which I think is really evil. Looking at you, Monster Scooter Parts. Evil, evil people. So that's why I make videos like this, so you can all repair your stuff for free. So, okay, I got my screwdriver under here. Again, it's just a flathead bit. You want to match it, you know. Here's what I'm trying to get into, by the way, is this flathead, which is the end of the potentiometer there. And so while those Allen bits are loose, I'm going to be turning this ever so slightly to the right, which I just did. Maybe a tiny bit more. And once you do a turn like that, go ahead and turn your key back, turn it over. All right, solid green, that's a really good sign. And this part's tedious because now all you can do is tighten these, which is going to also affect the alignment because it really is that sensitive. So even just tightening these bolts is going to affect that dead spot. Maybe I shouldn't call it a dead spot. A dead spot refers to when a potentiometer is actually broken, but it's the default state. The home position is maybe a more accurate term. But even by tightening these bolts, I'm actually affecting their resistance, because again, it's just incredibly sensitive. All right, but now let's see what happens if aha. So now I've actually got it the other problem, where it takes quite a turn here to go in reverse. It only starts actuating right really close to the handle, whereas going forward, it's fine. So that means two things could happen. One, I could get a little more speed out of it right now in this position, which is kind of cool. But also, if you go too far, then the microcontroller also knows that your alignment is off, and it will oftentimes stall. And I don't want that to happen either. So I'm going to loosen this one more time. Well, now I'm just going to go in here and just do just the hair of a turn. It's got to be just the most tiny turn here. Like that. Absolutely, it's like a 1/32 turn. And let's see what that does. And you'll even see this thing kind of moves when you tighten this. Again, part of its incredibly bad design that I'm going to be rectifying with my own design later. And you want these to be fairly tight. I mean, not so much that you're bending it, but because it's not a type D or a knurled shaft, it means it's prone to moving around that shaft, which is ridiculous. All right. And yeah, I moved it too much. So I'm gonna do this one more time. Can you believe that that little tiny amount was actually too much? You know, for all my complaints, I have had this chair for a long time. Yes, I've had to do a number of repairs to it, but I do like it a lot, which is obviously why I have it. I'm going to go down in here. Let's just do the tiniest hair of a turn. Like I said, this is tedious. There's no way around it with these kind of mechanical things. And it's just a combination of so many factors. Bad choice for potentiometer, bad programming in the microcontroller. That's pretty good. So it actuates there for the reverse, and then there for the forward. Yeah, that's almost perfect. It's just a little bit off as far as I wish it would go a little bit further to actuate the reverse, but that's really good, especially because I'm going to be upgrading this anyway later on with a much better, completely redesigned system. But yeah, it works. I'm going to go ahead and turn the key back, turn it over, and yay, everything's nice and working. You can also hear the motor brake engage. You hear like those clicks, especially after you wait a second or two. That's another way to tell when you've hit that home spot, is you'll hear down in here where the transaxle motor is, you'll hear the brake click. I'll try it one more time. There's that second click. That's the full stop brake, and so that won't click into place unless, of course, it thinks this is in the stop position, the home position. So that's another way you can sort of audibly assist yourself to make sure this is working properly. This spring I've never had to replace, but this one's definitely looking rusty and not so hot. Something to keep in mind. And the way this works is there's two pieces of metal that push against this spring-loaded clip here. And because the spring is on the right, it's not actually balanced. You don't get equal force, which is another design flaw. But I have another video where I go into some of those design flaws. Anyway, hope this one helped you. Feel free to leave a comment. I'll try to help if I can. Like I said, I'm going to be trying to design a better version for this, but of course there's so many different wheelchairs out there. It's hard to make a universal design. But one of these days, my hope is to actually design something from the ground up and really help a lot of people and myself in that process. So yeah, hopefully this was helpful to you. I'll have more videos like this. Keep checking them out. Keep coming back. Catch you all later.